Lesson 7F, Friction Force Calculations. Remember, the formula for friction force is mu times force normal. So if you have an object on a horizontal surface, then force gravity equals force normal. Fg equals Fn. So if force gravity equals mass times gravity, then force normal equals mass times gravity. We simplify friction force as mu times mass times gravity. Our first example, mobster Robbie drags a coffin across the wooden floor at a constant velocity with a horizontal force of 720 newtons. The coffin weighs 1200 newtons. The key here is constant velocity. First, draw a free body diagram, then find the mass of the coffin, and finally, find the coefficient of friction between the floor and the coffin. Let's draw the coffin as a square. Fg equals 1200 newtons. There's a force normal that keeps the coffin from falling through the floor, which must be equal but opposite, so 1200 newtons upwards. There's a force applied of 720 newtons. Now, since the coffin moves across the floor with uniform motion, it's not speeding up or slowing down, it's not accelerating. The force friction must also be 720 newtons, but in the opposite direction. There is zero net forces acting on the coffin, therefore it does not accelerate. It does, however, keep traveling at a constant speed in a straight line across the floor. What's the mass of the coffin? Here's the free body diagram. Remember, Fg equals mg. 1200 newtons equals mass times 9.8 newtons per kilogram, g. M equals 1200 newtons divided by 9.8 newtons per kilogram. We're left with mass equals 122.45 kilograms. The coefficient of friction between the floor and the coffin. Friction force equals mu mg, which equates to 720 newtons. 720 newtons equals mu times 1200 newtons. Mu equals 720 newtons divided by 1200 newtons. Notice how the newtons cancel out, leaving mu a unitless value of 0.60. The coefficient of friction is 0.60. Kinetic friction versus static friction. Remember from last lesson, kinetic friction is the force present when objects are already sliding or moving across each other. It resists the movement and results in slowing down of a moving object. It can be used in free body diagrams to calculate Fnet and acceleration. Static friction, on the other hand, is the force present when objects are stationary and an attempt is made to make them move. It's a force that resists the object from moving initially. It's a necessary type of friction when we want movement between two parts, like shoes on the ground or tires on the road. Example number 2. You have been asked by your good friend Robbie to move a box. The box weighs 65 kilograms and you and your friend apply a force of 140 newtons purely in the horizontal. The coefficient of static friction, mu sub s, is 0.20, and the coefficient of kinetic friction, mu sub k, is 0.15. What is the free body diagram? Will the box move? And finally, if so, what's the acceleration of the box? Here we draw the box. Here's force gravity. Here's force normal, since the box does not sink or rise. Here's the applied force of 140 newtons. Here's the arrow representing friction force, which we don't know the value of yet. Does the 65 kilogram box move? Here's your free body diagram. Remember, for the box to move, applied force must be greater than static friction force. Static friction force is mu sub s times mg. Static friction force equals 0.2 times 65 kilograms times 9.8 newtons per kilogram. Notice how the kilograms cancel out. Static friction force is 127.4 newtons. Remember, applied force was 140 newtons. Since the applied force is greater than the friction force static, the box will move. Now that the object is moving, we need to calculate the kinetic friction force, and we can ignore the static friction force. Kinetic friction force equals mu sub k mg. Kinetic friction force equals 0.15 times 65 kilograms times 9.8 newtons per kilogram. Kinetic friction force is 95.55 newtons. Now let's consider this. Who wins the tug-of-war? Does applied force win, or does kinetic friction force wins? Applied force is 140, while friction force is 95.55. Therefore, applied wins. Fnet equals winner minus loser. So, Fnet equals force applied minus force friction kinetic. Fnet equals 140 newtons minus 95.55, which is 44.45 newtons. Recall, the formula for Fnet is mass times acceleration. Therefore, 44.45 newtons equals 65 kilograms times acceleration. Isolate A, 44.45 newtons divided by 65 kilograms gives us 0.68 newtons per kilogram, which is equivalent to 0.68 meters per second squared. The box will accelerate across the floor at a rate of 0.68 meters per second squared.